who the hell came up with a square root of a negative number? I mean, I know that in math you would never be able to do that. And of course, you have heard this in the real numbers. Now, what does that mean? Of course, I know it is not intuitive to think how the hell do you compute the square root of a negative number? No two numbers, not there's not a number squared that can give you a negative number. Okay, that's not possible. And of course, that's the intuition we all have. But now I want to show you a new perspective into why complex numbers are needed and into why they actually to some extent do exist and how you can apply some intuition into them. Okay, and of course this comes into play when solving some sort of equations that have no real solutions. So in order that we can accomplish our goal, I'm going to use some equations. Okay, so now let's say we have the following equation: x plus 1 squared is equal to minus 9. So now we know, straightforward, that if we have any number squared, we cannot get a negative number in the real numbers. But now try solving this equation at home. There is no number x that you can replace in this equation so that you get minus 9. No number in the real numbers. Now, there is something that a lot of times in math you do things that might not seem so intuitive, but at the end of the day they work. Okay, and they work in order to get a solution to an equation to work. Okay, I mean, it's like redundant, but you do things that work or that may not make that much sense so that they work into providing you with a solution to an equation. Let me show you what I'm saying. So this equation, we can solve it if we say that x is equal to minus 1 plus 3 times the square root of minus 1. Now you're gonna say, well, this doesn't exist. I know, I mean, numerically you're never gonna find that square root of minus 1 is something. But try now, replace x with this value. Well, we would get something like this. We would get minus 1 plus 3 times the famous number I, but I'm just going to write it as square root of minus 1 plus 1 squared is equal to minus 9. Now you probably see where I'm going. The two ones, they go out, and you're going to get 3 times square root of minus 1 squared should be equal to minus 9. Now you can distribute the exponent into the two numbers. So you would get 3 squared, that is equal to 9, now times the square root of, and I'm going to write that over here, the square root of minus 1 squared. You know the square and the square root, they go out, and you're going to get minus 1. So you get 9 times minus 1 is equal to minus 9. And this equation is in fact true. We had to use complex numbers or imaginary numbers, non-real numbers, because this number does not exist, but this proves my point. We're doing something that works. Okay, it is not intuitive how it works, but it works. Okay, if you plug in something in there, I think that's the beauty of maths. You know, just things apparently work and we may not be able to see how, but they work because they have relationships between numbers. And well, this square will take out this radical, and you're gonna get 3 times negative 1. That gives you negative 9. And 9 times negative 1, and that gives you negative 9. Okay, so I think that's something pretty cool about math. Some things it is not so intuitive to see them, but they work. Okay, and we have discovered that they work, and therefore we can use them. So now I want to show you another example that might be a bit more common. So for example, let's say we have the equation x squared plus 1 is equal to 0. Now once again, in order that this equation works, you would need the x squared to be equal to minus 1. Once again, if you square any number, you're not going to get any negative number, okay? Not in the real numbers. It's funny to say not in the real numbers. I don't know when we're talking about non-real numbers, it's like kind of redundant always saying that. So anyways, once again, what can we do here? Well, if you think about it, radicals go out with the squares, and we can say that I, now I'm not gonna write square root of minus 1, but rather I squared plus 1 is equal to 0. This equation is in fact true. This is actually when x is equal to any real number. That's not true, okay? Actually, this is the worst notation I have ever used. Well, when x belongs to the real numbers, this will not happen. However, if x belongs to the complex numbers, that means x is equal to I, then that works. Because this is equal to the square root of minus 1 squared plus 1 equals 0. This is just simply minus 1 plus 1 is in fact 0. So I hope you have seen some intuition here, okay? Just keep in mind that math is about relationships. Sometimes our human minds will not be able to get those relationships with, straight intuition, but mathematicians have discovered that those relationships will lead you to something, okay? And that allows you to solve equations and to, develop bigger problems, okay? And that is the whole idea and probably the greatest degree of intuition that you can get about complex numbers, okay? So I hope you guys enjoyed this video, and I hope to see you in the following ones.